So recall on Tuesday, we were talking about how to measure a variety of economic variables that are of interest to us. So we started by talking about measuring economic activity through GDP, and we saw that we can measure it any one of three different ways. The product approach, or production directly. We could look at expenditures, or what's being bought, or we could look at the income that's being generated. We also talked about inflation, unemployment, and interest rates. Now recall that when we were talking about interest rates at the very end of class on Tuesday, we were making a distinction between real interest rates and nominal interest rates. So nominal interest rates simply tell you how much your principal is going to grow per year over the course of the loan. So if you borrow $100 at a nominal interest rate of 5%, a year from now it'll be $105. 2 years from now it'll be $110 and change, right? So that's the nominal interest rate. The real interest rate is going to tell us what the purchasing power of that increased principal, nominal principal, will be. So in this case, we also have to take into consideration what happened to inflation. So even though your $100 becomes $105 a year from now with a 5% nominal interest rate, the other thing we'd want to know is how much did prices go up by? If they also went up by 5%, then your real interest rate would be 0. Your purchasing power a year from now would be exactly the same as it is today. If inflation, however, went up by something less than 5%, then you would have an increase in your purchasing power a year from now, which would imply that your real interest rate has been positive. Of course, it's also possible that inflation was greater than 5%, in which case the purchasing power a year from now is worth less than it is today. That is, the basket of goods and services that you could buy would be smaller a year from now than today. The real interest rate would have been negative. Not a very good situation to find yourself in. So we had been talking about real interest rates during that period of time, so in nominal interest rates. And now we want to take a look at something known as the Fisher equation. The Fisher equation just shows us the relationship between nominal and real interest rates. The Fisher equation is named after Irving Fisher, an American economist who did most of his work in the 19-teens and the 1920s and the 1930s, so a long time ago. So what Irving Fisher realized is that the nominal interest rate is really nothing more than the real interest rate plus the expected future inflation rate. So purchasing power, real interest rate, plus whatever expected inflation is going to be. And he argued the expected inflation that we should look at, is the ex ante, right? Our forward-looking expectation of inflation, rather than calculating it looking backwards. So if the nominal rate is equal to the real rate plus the expected rate of inflation, we could use that equation to solve for the real interest rate, which would simply be the nominal rate minus the expected inflation rate. Now, the problem with using the Fisher equation, by the way, both those forms are called the Fisher equation, just to confuse people, but we could use either one of these forms of the Fisher equation to actually figure out what expected inflation was going to be. Right? Take the equation, solve for expected inflation. Whoops. And when you do that, what you realize is that expected inflation is nothing more than the nominal interest rate minus the real interest rate. Right? So that gives us then at least one way of measuring expected inflation. As we'll see later, having an idea of what expected inflation is, and especially how it is changing or not changing, turns out to be very, very important for short-run business cycles. The problem in this, of course, is that while the nominal interest rate is easy to observe, the real interest rate is much harder to see. Most borrowing and lending activities do not take place using real interest rates. In the United States, however, we've been fairly fortunate. Starting in 2003, the U.S. Treasury began to issue debt instruments with a real interest rate associated with it. So we actually have real interest rate measures for the last 13 years. So from that, we can calculate a measure of expected inflation. And this is what it looks like. So this is the nominal interest rate minus the real interest rate on comparable 10-year Treasury securities. So this would be what we expect inflation to average over a 10-year period. Now, there's a couple of things here that I think are important to recognize. One is, before the economic crisis, expected inflation appeared to be around 2.4%. And since the crisis, a little more volatility, but it seems to be about 2.3%. So it's come down a little, but not very much. However, it also changed quite significantly during the economic crisis. So one of the things that we will have to look at and to think about is, why would expected inflation change during an economic crisis? We would also like to think about the implications of a relatively steady inflation expectations over most of this 14-year period, or 11-year period, because I can't do math in my head. Okay? So those are things that we're going to look at. Now, before we go on to today's lecture on production functions, I want to circle back because several people asked me a question about gross domestic product and gross national product. So this is a slide that I had in our presentation on Thursday. Gross domestic product, remember, is how much we're producing within the geographic boundaries of the country. We know that some American productive assets, workers and capital, actually earn money abroad. And they send some of that money back to the United States. And inside the United States, there are foreign assets, workers and capital, that earn money inside the country, and they send some of that money outside the country. The money coming in is what we call factor income from the rest of the world, and the money going out are called factor payments to the rest of the world. Right? So we want to adjust for the money coming in and out to see how much money or funds are inside the country to be spent. Right? That's the income side that we want to look at. So these two items here are referred to as net factor income when we combine them. So we would say then that GDP plus net factor income equals gross national product, or gross national product minus net factor income equals gross domestic product. Now, I only emphasize that because this chart is in your textbook. And if you look at it, what it says is gross national product minus 257 net factor income equals gross domestic product. Therefore, it looks like it's a subtraction, but I just told you it was an addition. Right? We add net factor income to gross national product to get net national gross national product. Now, you may remember on day one of the things that I told you is one thing that makes macroeconomics so controversial is that some people just won't listen to me. There's a typo in this chart. It's the minus sign. The explanation of this in your textbook is also incorrect. It was also incorrect in the first edition, and I pointed it out to the author, and he still hasn't changed it, which is why we have controversies. Just listen to me. So it turns out that net factor income from the United States is not a negative number, it's a positive number. That is, we receive more income from the rest of the world than we pay out to the rest of the world. So my diagram is correct. I knew it was correct. I took it from the government document. And if we eliminate that minus sign, we're in good shape. I think where they got confused, they have the right number. Everything else is an addition. I think what he meant was gross national product minus a positive number. The minus sign is the arithmetic operation, not the value. But anyway, I just wanted to clarify that. Okay, so we now know how to measure a bunch of big economic data pieces. We can look at patterns in that data, and then that helps us to formulate a story or a theory about how those data are related, and that allows us with the data to actually test our models and to see whether or not they work in the real world. So let's actually talk about a model. So the question that we want to ask ourselves here is, how much output could the economy produce? And what is it that determines how much output the economy could produce? So that might be interesting. We know that GDP in the United States is roughly $17 trillion. What accounts for all of that? How do we actually do that? So when we want to think about how we generate aggregate production in the economy, we need to step back and look at something known as a production function. So the way that production works is we can think about this as inputs coming into a black box and output coming out of the black box, right? So we got to have stuff coming in. That might be, we need some workers, we need some machines, we need a building, we need some raw material inputs, iron ore, or electricity, or paper, whatever it is that we need to produce the goods and services that we're looking at, and then we do something with all of that inside that black box, and boom, out comes the output that we're producing. So we could think about this for a steel mill, we could think about this for a legal firm, we could think about this for the entire economy. So what we see when we look at this approach is that how much you can produce depends upon three different things. First, how many inputs do you have? Those inputs are what we call factors of production. How many workers? How much machinery? How many buildings? How much raw material inputs? Right? Factors of production come into the production process. The second thing that it depends upon is the production function itself. The production function simply tells us what combinations of the factor inputs we can use. Right? How many workers do we need per machine? Right? If it's a laptop computer, chances are we only need one worker per machine. If it's an oil refinery, though, we probably need several hundred workers for that one oil refinery. Right? So that's what the production function tells us, is what is the combinations, the various combinations of the inputs that we can use to produce output. And then finally, the third thing is what we refer to as total factor productivity, or simply productivity. Now, I'll warn you, your textbook sometimes calls this, technology, a term I will not use to refer to productivity. Remember those controversies? Okay, this is another one of my big gripes. Okay? There's a difference between technology and total factor productivity. We want to focus on total factor productivity. Total factor productivity basically tells us how efficient are we in using our inputs, factors of production, to generate output. Right? Some of us may be very, very industrious, and we can get a lot of output out of any given amount of inputs. Some of us maybe not so industrious. So with exactly the same inputs, we wouldn't get as much output. Right? So that's one way to think about total factor productivity. At the aggregate level, that is at the national level, we only consider two factors of production. Labor, the number of workers that we have, the number of hours that they're working per week, per month, per year, and the capital stock that we have to work with. That is the productive physical assets that we're dealing with. How many machines, how many factories, how many office buildings, right? How many computers, how many printers, how many wireless routers, all those kinds of things would be factors of production in the capital side. Okay? So we don't need to consider other factors of production. It's interesting if you think about it. Japan has the third largest economy in the world, and something like the 7th, 8th, 9th highest output per person in the world. And yet, they don't have any domestic crude oil. Boy, wouldn't you think that having crude oil would be important to your production process? Well, you can't produce things without energy. And most energy comes from petroleum products. And Japan doesn't have any. Zero. Nothing. So why don't we consider things like energy in here? Well, Japan clearly doesn't need to have its own energy. Right? Because it can buy crude oil in a global marketplace. It needs to be able to buy it, use it to produce other things with its labor and capital, which it will then sell in order to pay for the crude oil that it wants. In the early 1960s, Japan was the world's largest steel maker. Japan has no iron ore. How can you be a steel maker without your own iron ore? It's easy. You buy it from Australia. You buy it from Canada. You buy it from Russia. You buy it from the United States. Right? So we don't need to consider the raw material inputs. Well, if you've got the labor and the capital and also the total factor productivity, you can buy all the other inputs that you want. Okay? And again, total factor productivity then simply tells us how efficient are we in using our factors of production to produce output. So a very easy equation for an economy's production function is simply to say that economic output is dependent upon total factor productivity and some function, that's what the F means, of capital and labor. So this is our aggregate production function. Single equation. Now in this equation, economic output is our endogenous variable. Total factor productivity, capital, and labor are exogenous variables. Now if we expand the model, which we will be doing over the next couple of weeks, we will see that some of these currently exogenous variables might become endogenous variables. Okay? So just because we start off with a set list of endogenous and exogenous doesn't mean we end up with the same list. Okay? So this is our production function. Right? How much output we can get, Y, depends upon how much capital and labor, factors of production we have, through the application of total factor productivity, A. Now, total factor productivity is the hard part to get our hands around. Right? It's pretty easy to imagine, what do we mean by labor, right? Presumably, most of us are going to be workers at some point, or have been workers at some point, so it's easy to figure out what we mean by labor. And capital is pretty easy to think about as well, since most of us actually use capital in terms of whatever it is that we're doing, right? Buildings, chairs, projectors, screens, laptops, all those things, pens, pencils, all of those types of things can be thought of as capital. But total factor productivity isn't like that. In fact, total factor productivity is not a physical thing at all. Rather, total factor productivity is kind of like a recipe. It tells us how to use our factor inputs, right, labor and capital, how to use them to produce output. So if I gave you a mixing bowl and a whisk and some egg and flour and salt and sugar and a few other things, and I told you, make me a cake, right? Make a cake. Right? So we know what our inputs are. Presumably we've got an oven as well. But how you make that cake, how efficient you are, how good that cake tastes at the end of the process depends upon the recipe you use. Right? The recipe is just a set of ideas about how we do things. So total factor productivity then can be thought of like recipes as the ideas that we have about how to work with our factors of production. And that's what we mean by total factor productivity. So this is one measure of total factor productivity for the United States. This is simply an index number based in 2009. But one of the things that you can see is total factor productivity has risen quite dramatically over the years from a level of slightly above 25 to a level of slightly above 100. Big increase over the 65-year period. Now remember, if we think about our production function, notice that a big increase in total factor productivity, even if this side doesn't change at all, also means a big increase in real economic activity. Remember, real economic activity is also real income. So big changes in total factor productivity translate into increases in income and therefore to an economic standard of living. Now the other thing to notice is this is not a smooth line. In fact, you can see it's kind of jaggedy, which means that total factor productivity does on occasion fall. And indeed, if we were to look at this on a year-over-year growth basis, we would see something that looks like this, which basically looks like what happened in Napa Valley a week and a half ago. Right? I mean, this looks like an earthquake Geiger counter, a Richter scale, excuse me. So it's really hard to figure out what's going on there. There's so much volatility in this data from one year to the next that it's hard to figure out an underlying trend or to know what's happened. So a better way to look at that is to go back to levels, but now look at it in natural log terms. Right? Everybody loves logarithms? Let me try that again. Everybody loves logarithms? Yeah, okay, good. So that's better. Okay, so let me tell you what this means when we put it into logarithms. So once we take that level data, again, this is just what we saw in that first chart, but to change the vertical axis to natural logarithms. The reason that we do that is that the slope of the line now tells us what the growth rate of that line is. So what we can see is that roughly from 1950 to 1973 or 74, we had a pretty steady growth of total factor productivity. Now also, you can see that that trend line got broken, and you can see what the shortfall has been simply by extending that. In other words, if over the last 35 years, total factor productivity had grown just as fast as it did between 1950 and 1974, we would actually be looking at total factor productivity that would be about 20% higher than it is today. Remember, what that means is we're poorer today as a nation and as the average individual in the nation than we would have been had we been able to maintain the same total factor productivity growth that we had seen in the 50s, 60s, and early 70s. Also notice that this productivity trend, there, is fairly weak from the mid-1970s to the mid-1980s. And fortunately, if we extend that trend, you can see we're doing a lot better than that. And then roughly from the mid-1990s up until the advent of the Great Recession in 2008, we saw stronger productivity growth. That's supposed to be a solid line. And it looks like we were growing almost as quickly as what we were back here. We weren't catching up. We weren't narrowing the gap, but we weren't falling further and further behind. Unfortunately, over the last 5 or 6 years, productivity growth has gone relatively flat. Now, we'll be talking about why some of these big changes happened, but these are the 3 big breaks in productivity growth. 1973, the first OPEC oil price shock. 1995, the commercialization of the internet. 2008, the severe onset of the global financial crisis, the failure of Lehman Brothers, et cetera, et cetera. Okay? So big economic events can have make big changes to productivity, which can have long-lasting effects in terms of our aggregate economic output as well as our aggregate economic welfare. So with that in mind, let's think then about production functions. Now remember, this production function that we're working with has 4 variables in it.